Hello dear students, welcome grade 11. Today we are going to represent part 4, the first derivative. Today we are going to focus on the first derivative of composed functions, chain rule. Do you remember our objectives? 8 points. Today is number 7. We are going to explain number 7. The first derivative of composed functions using chain rule. Chain rule, it means relation between more than two functions. As here we have h, we have g, we have f. Three functions, and f related to g and g related to h. So let's study how to find the first derivative of h dash when I plug f inside g. The rule is derivative of outside and leave the inside, and then derivative of inside. Dx, I'm going to multiply derivative of y with respect to u and derivative u with respect to x, and then find the product. For example, if I have hx, putting here, I have hx equal fx up to power n. Function has a power n. How to find the derivative when the function has a power? Read here, derivative of outside the function, leave the inside alone, then derivative the inside. Like derivative if the bracket fx up to power n, bring down the power n as a coefficient, decrease the power by 1, and they leave the inside alone, and then multiply by the derivative of the inside. Example, find the derivative of gx equal square root x squared plus 1. Let's see how to find the derivative if I have an expression, not simple, we have a root. First step, I'm going to rewrite the expression or the function using the power function. It's going to be gx equal bracket x squared plus 1 up to power half. What happened? I replaced the square root to be power half. Then I have function x squared plus 1 raised to power half. Two steps. Derivative of the outside multiply derivative what? Inside. Again, derivative outside, leave the inside, and then derivative the inside. Look, the power half, I'm going to bring it down to be coefficient, and then reduce the exponent by 1. Half, multiply the bracket, and half minus 1 is negative half. Multiply derivative the inside, like x squared plus 1. Okay? Half x squared plus 1 up to power negative half, and derivative x squared, it's 2x, derivative constant 1 is 0. Now I can reduce. How come? Cross out 2 with the 2. Cross out 2 up with 2 down, and then we have up 1 times the x, it's x. What's about x squared plus 1 up to power negative half? How to ignore negative sign? Flip. Yes, flip x squared plus 1 from numerator to be denominator, and the power half changed to be square root. Another example. Find the derivative of fx equal 1 over 4x squared minus 7 all power 2. Yes, first I'm going to flip the function to be 4x squared minus 7 power 2 from denominator to be numerator. What happened? We changed the sign of the power 2 to be negative 2. And now, since I have a function raised to a certain power, so two steps. Derivative outside, leave inside, multiply derivative inside. Apply اللي هو الجنرال باور رول. Derivative outside drop or bring down the exponent to be a coefficient and then reduce the exponent by 1. It's negative 3. Multiply derivative inside the bracket. Derivative 4x squared, it's 8x. Derivative constant 7 is 0. Now I'm going to multiply negative 2 by 8x. It's going to be negative 16x. And flip 4x squared minus 7 up to power negative 3 to be denominator and change the power to be positive 3. Rule number 7, the chain rule. Another situation, I need to use the chain rule. يبقى two situations we use the chain rule. The first, as I explained with two examples which we explained. And now, if I have dy over dx, I'm going to multiply dy du by du over dx. Example. If I have y equal z squared and z equal x power 4 minus 6, find dy over dx. Here, it's clear that y related to z and z related to x. Okay? So I can find derivative y dy to dz and dz over dx. And multiplying dy over dz times dz over dx by simple way, I can ignore dz with dz to get dy over dx. Again, since I can find dy over dx and dy over dz and dz over dx by ignore, I can cross out dz over with dz, I will get dy over dx. Okay? Okay. Let's find dy over dz. Derivative of z squared, it's 2z times dz over dx. Derivative x power 4, it's 4x power 3, derivative L6 is 0. Now, I can replace, you have must here. You have to replace Lz by what? X power 4 minus 6. يبقى 2 bracket x power 4 minus 6 multiply 4x power 3. Again, derivative or dy over dz and then dz over dx. Multiplying, you will get dy over dx. Okay? Because I can cross out dz with dz to get dy over dx. Okay? And replace Lz by a given function x power 4 minus 6 and remove the brackets and multiply to get 8x power 3 x power 4 minus 6. 2 times L4, it's 8x power 3 multiplying x power 4 minus 6. Another example. I have y equals z power 3 plus z and z equal x squared minus x. Find dy over dx at x equal 2. As we see, there is a relation between y and z and another relation between z and x. But required to find dy over dx. Since there is no direct relation between y and x, but I have z as a common factor, so First step, I'm going to find dy over dz from the first function and dz over dx from the second function, and when I cross out the dz with the dz, we get dy over dx. First part, dy over dz, I need to finally calculate or evaluate the derivative of z power 3 plus z. Derivative z power 3 is 3z squared. Derivative in z 1. Multiply derivative in z with respect to x, which here x squared to x. Derivative in x 1. Okay, and now we need to replace z by what? X squared minus x, to convert all the variables to be x. One variable, x. So I'm going to replace z squared by x squared minus x, all power 2 plus 1, multiplying 2x minus 1. And then plug the x by 2. Each x here, I'm going to replace it by 2, and the final answer is going to be 39. Now we have practice example, but you have to do by yourself. Number 1, find the derivative of hx equal x squared plus x plus 1 up to power 100 at x equal 1. That in the first case, we need to use chain rule because I have a function raised to power 100. If I first situation, if you have a function raised to a certain power, you need to use chain rule. How come? Derivative the outside and leave the inside. Multiply derivative the inside and then replace the x by 1. Second case, which we need to use the chain rule, if I have a relation between y and z, z and x, and required to find dy over dx. How come? Find dy over dz and then dz over dx, and then by multiplying you get dy over dx and replace the x by 3. Attention please. After watching the video, write down your answers and comment below, because if you did, you will get 5 marks bonus. Thank you, grade 11.